Bismillahirrahmanirrahim. Quote of the day: Hope is like the sun which, as we journey toward it, casts the shadow of our burden behind us. Assalamu alaikum. Today, the topic of my presentation is Z-test for mean, under kind supervision of Professor Dr. Saira Afzal. Learning outline of my today's presentation is about introduction to Z-test, a brief overview about null and alternative hypothesis, formula to calculate Z-test, steps for solving a hypothesis of Z-test, examples of Z-test, and MCQ session at the end. By the end of this presentation, participants will be able to describe about Z-test, where to use Z-test, and how we calculate Z-test and implement the Z-test. First, we discuss about the introduction of Z-test. Z-test is a statistical procedure used to test an alternative hypothesis against a null hypothesis. It is a statistical test for the mean of a population. Z-test is a statistical hypothesis used to determine whether two samples means are different when variance are known and sample is larger than 30 in numbers. It is a comparison of the mean of two independent groups of sample taken from one population with known variance. First, we clear the concept of null hypothesis and alternate hypothesis because over Z-test based on these two parameters. Null hypothesis is a statistical hypothesis that states that there is no difference between a parameter and a specific value, and or that there is no difference between two parameters. This is how we represent over null hypothesis. It is a hypothesis which the researcher tries to disprove, reject, or nullify. The null often refers to the common view of something. Alternative hypothesis. It is a statistical hypothesis that states that the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters. This is how we present over alternative hypothesis. It may be a right tail or left tail, or the value may be lesser or greater. Is what the researcher really think is the cause of phenomenon. This is the classification of Z-test or T-test. These two tests are a parametric test, and we can divide it into one sample Z-test or a two sample Z-test. And then a one sample is further divided into T-test for mean or a Z-test for mean. And in the two sample, we categorize it into an independent sample or a paired sample, which also known as dependent sample. And independent sample are further divided into two group T-test or a two group Z-test. And a paired sample is divided into paired T-test. So you can see that there are three major type of Z-test. One sample Z-test, and in the two sample Z-test, there are only independent sample. Not dependent sample is the type of Z-test. It is the type of paired T-test. This is the journal formula which we applied on every statistical test. It is written as observed value minus expected value and divided by a standard error. Now we see what are these word stands for. The observed value is the statistic such as the sample mean that is computed from the sample data. The expected value is the parameter such as the population mean that you would expect to obtain if the null hypothesis were true, and a standard error, the denominator is the standard error of stat And in this case, the standard error is the standard error of the mean in case of z-test. This is the formula which we are used for the calculation of the z-test. This is over sample mean, this is population mean, and this is the standard error of mean. Why we use lot sample for the z-test? When we perform a statistical test, we are trying to judge the validity of a null hypothesis. We are doing so with an incomplete view of the population. Over sample is over window into the population. The larger the sample size, the bigger over window. However, without a full view of the population, there is always the chance that our sample will lead us to the wrong conclusion. Why we do use the z-test? When sample are drawn at random, when the sample are taken from population are independent, when standard deviation is known, and when the number of observation is large, greater than 30. These are the 5 steps which are we use for solving our hypothesis of the z-test. First, we state the hypothesis into 2 categories, alternate and null hypothesis and the alternate hypothesis. Then we find the critical values according to the alpha, according to the level of significance. And then we count over test value by using the z-test, and then make the decision whether reject or not reject the null hypothesis, and then we summarize over results. This is the step 1, that how we claim the null hypothesis and alternate hypothesis. These are the situation of null hypothesis, and these are the situation of alternate hypothesis. Then the number 2 is the critical value. And the critical value, we use the level of significance and the level of confidence. There are mainly 3 levels of confidence, 1%, 5%, and 10%. And according to the confidence interval, these are 1% is the 99% confidence interval, and 5% is the 95% confidence interval, and the 10% shows the 91% confidence interval. And this is the level of confidence. And then z tables are used and depend on if hypothesis is one tail or two tail. This is the distribution curve. This is the do not rejection area, and this area is the rejection area. Rejection area shows the level of significance, and the level of confidence is shown in the not rejection area. This is the formula which we use for calculate over z score. And then we make the decision to reject or not reject the null hypothesis according to the z values, or depending on the calculated z value, whether it is lie in the rejection region or not rejection region. And then we summarize over results. Now we shown the example how we calculate the z-test. A researcher reports that the average salary of assistant professor is more than $42,000. A sample of 30 assistant professor has a mean salary of more than $43,260. At level of significance at alpha equals to 0.05, test the claim that assistant professor earn more than $42,000 per year. The standard deviation of the population is $5,230. Now I will show you how we solve this example. First, we state the hypothesis and identify the claim. Our null hypothesis is the salaries of a professor is equal to $42,000, and our alternate hypothesis is the salaries of assistant professor is more than $42,000. This is the claim of a researcher. Now we solve this claim. Find the critical value. because the level of confidence which is given is the 0.05 and the test is the right tail test. 0.05 is the 95% confidence interval, and at the 95% confidence interval, the value is the plus 1.65. So the our critical value is plus 1.65. This is our formula. This is the sample mean, and this is the population mean, and this is the standard error. And the result which are drawn is 1.32 is over z-score. Since the test value, which is plus 1.32, is less than our critical value, which is plus 1.65, and it is not in the critical region. So our decision is to not reject the null hypothesis. And when we summarize our result, there is not enough evidence which is support that the claim of assistant professor salary is more than average $42,000 per year. So our alternate hypothesis, so we cannot reject our null hypothesis. Now comes the two sample z test. In a stats, a two sample z test for mean is used to determine if the mean of two population are equal. This test is used when the population standard deviation are known. Formula for the z test for comparing two means from independent population. This is the formula which is used for independent population and a two sample z test. First, we discuss one sample z-test, whether it is right tail or a left tail. And now we discuss two sample z-tests by using this formula. Hypothesis testing situation in the comparison of a mean. This is the independent population and two sample population. This is one sample and this is two sample. When our results are equal, there is difference is not significant. And when difference is not significant, we cannot reject or null hypothesis. And if there is a difference in two population is significant, then we reject over null hypothesis. This is the example of two sample z-test for independent population. A survey found that the average hotel room in a New Orleans is $82.42 and the average room rate in Phoenix is $80.61. Assume that the data were obtained from two samples of 50 hotels each and that the standard deviation of the population are $5.62 and $4.83 respectively. At alpha 0.05, again the confidence interval is 95%. Can it be concluded that there is a significant difference in the rate of these two hotels? Now state the hypothesis and identify the claim. This is over null hypothesis that there are no difference in the rate of two hotels, that there is these are equal, and in alternate hypothesis our claim is that there is no difference in the rate of two hotels, and our critical value is alpha is 0.05, so our critical value is plus 1.96 and minus 1.96. Compute the test value. This is the formula which is used and the result which are obtained is 7.45. So we reject the null hypothesis because 7.45 is greater than 1.96, which is over critical value. There is enough evidence to support the claim that the means are not equal. There is a significant difference in the rates. This is the table in which they show their different significance level which are used, 10%, 5%, or a 1%. And these are the, if you have one tail example, you compare your Z value to these levels. And if you have a two tail test, then you compare your Z value on this side. And these are the common significance level which are used. If you have two tail example, you compare your z value to a correct significance level on this side. For example, if you two tail z stats was 1.98 for the 5% level, you would compare it to 1.96 as it is greater. This is significance. So you can see in both of my two example which I can present, the alpha value is 0.05. It's mean 95% confidence interval, and we use one time 1.65 because this test is one tail, and second time we can use the value 1.96 because this example is two tail test. Now we solve our z test value by using the p-value method, and in a p-value method the steps are same, but we compare over z-score value with the p-value. When we obtain a z-score value, we put this z-score value in the calculator and we find out over p-value what is it. Step 1 is the state the hypothesis and identify the claim, compute the test value, find the p-value with the help of z-score, make the decision and summarize the result. Now we can see the example. A researcher wishes to test the claim that the average cost of a tuition and a fees at a 4-year public college is greater than $57,000. She select a random sample of 36 4-year public college and find the mean to the $5,950. The population standard deviation is $659. Is there evidence to support the claim at alpha 0.05? Use the p-value method. First, we state our hypothesis that the 4-year fees is equal to $57,000, and in the alternate hypothesis, the fees is greater than $57,000. This is our claim. Compute the test value, and the value which are obtained is 2.28, and now we find over p-value, and finding the corresponding area under the normal distribution curve. Z is 2.28 over z score. It is 0.9887. Subtract this value from this area of 1 and find the area in the right. 1 minus 0.9887. So the over answer is 0.0113, and over decision is p-value is less than 0.05, which is over alpha value. The decision is to reject the null hypothesis. Summarize the result. There is enough evidence to support the claim that the tuition and fees at your 4-year public college are greater than $5,700. These are different confidence level, 90%, 95%, or a 99%. And these are different p-values at this confidence level, 0.1, 0.05, and 0.01. And these are the critical values which are we set at this level of p-values or a confidence level. 1.65 to 1 plus 65, 1.96 to plus 1.96, and minus 2.58 to plus 2.58. How we use a p-value? If a p-value is smaller than the alpha, we reject the null hypothesis. If p-value is greater than the alpha, do not reject the null hypothesis. So in our example, p-value is lesser than 0.05, so null hypothesis was rejected. But otherwise, if p-value is greater than 0.05, so we cannot reject our null hypothesis. This is another example. The Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for a stroke victim is $25,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher select a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is $25,226. The standard deviation of the population is $3,251. At alpha 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from $24,672? So now we can see how we solve this example. State the hypothesis and identify the claim. Over a null hypothesis is the average cost is $24,000, and our alternate hypothesis that the average cost is not $24,672, and we find our critical value at alpha 0.01. It means 90% confidence level, and the test is a two-tail test. So our critical value is 2.58, and minus two, confidence level is 99%, 0.01, minus 2.58. Compute the test value. Over result which are obtained is 1.01. And when we decided, so we cannot reject the null hypothesis because the test value falls in a non-critical region. Over test result is less than over critical value, which is 2.58, and test result is less than this value. There is not enough evidence to support the claim that the average cost of rehabilitation is different from the cost of other hospital for the stroke victim. Now it's time for the MCQs. If a 99% confidence interval is constructed to estimate the sample mean with a non-variance, the correct critical value for a z-score is plus minus 1.96, plus minus 1.66, plus minus 2.33, plus minus 2.58, and plus minus 2.96.
Delta.
Delta is the right answer, plus minus 2.58. When test should a researcher use to determine whether there is evidence that the mean income of a doctor in Pakistan is greater than rupees 90,000? So this is one tail test should be utilized, two tail test should be utilized, left tail test should be utilized, two sample z test, or independent z test. A, a one-tail test should be utilized. If a one-tail z-test for a mean is performed and the upper critical value is, which we set is plus 2.33, and the test stat is equal to 1 plus 1.37, then what conclusion can you draw from this statement? The null hypothesis should not be rejected. The alternate hypothesis cannot be rejected. The null hypothesis should be rejected. The sample size should be decreased. The alternative hypothesis should be accepted. A is the right answer. The null hypothesis should not be rejected because our critical value is 2.33 and our answer is 1.37, which is lesser over critical value. So we cannot reject our null hypothesis. A sample size of 40 with a sample mean of 8.4 was selected from a population with a non-variance 1.2. The 95 confidence interval for mu. If we put all these value in a formula, which formula is correct by putting all these value? A, B, C, D, or E? A is the correct answer. 8.1 is over sample mean, 1.96 plus 1.96 over value or at 95% confidence interval, 12 and 12 divided by 12 is over population mean and divided by under root 40, which is over number of sample. The mean value of sample mean of iodine is expected to be lesser than the standard value of 20 milligram in people living at hilly areas. To test this claim, the researcher tested level of iodine among 30 people of the hilly areas and found the sample average X to be 14 milligram. What are the null and alternate hypotheses being tested? Exactly one option must be corrected. Which option is correct one? A, B, C, D, or E? D option is corrected because in alternate null hypothesis, they say that the sample mean is equal to 20, and in alternate hypothesis, D is correct. And in alternate hypothesis, they can say that the sample mean is lesser to the 20 and our answer is also 14 milligram. So D is correct one. Assume the cholesterol level in a certain population have sample mean 200 and a standard deviation is 24. The cholesterol level for a random sample of N is equal to 9. Individuals are measured at the sample mean X is determined. What is the Z score for sample mean if the sample mean is 180? This is quite mathematical problem. Any guess? B is the right answer. This is the solution of this problem. 180 over sample mean minus 200 and 24 under root 9. And when we solve over under root 9, it comes 3. And 180 minus 200 minus 20. 24 divided by 3, it comes 8. And when minus 20 divided by 8, the answer is minus 2.5. B option is correct one. A test is conducted where a null hypothesis of sample mean is 9 versus alternate hypothesis is lesser than 9. The test stat is minus 1.44. The correct conclusion is reject over null hypothesis at both level 0.05 and 0.10. Reject over null hypothesis at alpha 0.05 but not at 0.10. Reject over null hypothesis at 0.10 but not at 0.05. Reject null hypothesis at 0.01 alpha but not at 0.05. Reject over null hypothesis at both alpha 0.01 and 0.05. Minus 1.44 is our correct answer. Option C is correct one. Option C is correct one because we reject over null hypothesis at 0.10 because this is but not at 0.05 because this value is less than 0.10 but not less than 0.05. Researcher apply a z-test and computed a p-value 0.0113 at a level of significance alpha 0.05. What is your conclusion? Reject a null hypothesis. Do not reject a null hypothesis. Reject alternate hypothesis. Do not reject alternate hypothesis. Accept both hypotheses.
A.
A. Reject a null hypothesis because p-value is less than over level of significance. Suppose you start up a company that has developed a drug that is supposed to increase IQ. You know that the standard deviation of IQ in the general population is 15. You test your drug on 36 patients and obtain a mean IQ of 97.65 using an alpha value of 0.05. Is this IQ significantly different from the population mean of 100. These all values are given, but over solution A, but I ask you calculate only the standard error of mean by using these value, not not apply whole z-test, only standard error of mean. 1.5, 2.0, 2.5, 2.0, or a 3.5. Answer is 2.5. This is the solution, only standard error of mean. We use over variance and the number of sample. Variance is 15, number is 36. 36, when whole square is solved, this equals to 6, and when 15 divided by 6, the answer is 2.5. So only standard error of mean is calculated. The level of calcium in the blood of a healthy young adult varies with a mean of 9.5 milligram per deciliter and standard deviation 0.5. A clinic in rural Illinois measured the blood calcium level of 180 healthy pregnant women and find X, which is equal to 9.57. Is this an indication that the mean calcium level in this population differs from 9.5? Option 1.66, 1.80, 2, 2.33, or a 2.60. The answer is D, 2.33, and this is the solution. This is our null hypothesis, and this is our alternate hypothesis. And when we put all values in this formula, we obtain our result, which is 2.33. This is the key of my MCQs. This is the link of YouTube channel where the all videos are uploaded, and thank you.